Assalamu alaikum. Today I am going to explain interior and closure of assets. So first of all, the definition of interior of sets and closure of sets. Let A be the subset of topological space, X be a topological space, and let A be a subset of topological space, and the interior of A is denoted by int of A and or A bar means dot a dot is the union. What is the interior of A? Interior of A is the union of all open sets. Open sets, we know that about the open sets. Open sets, the subsets in topology is called open sets. The union is the union of all open sets contained in A. All the open sets contained in A. Open sets, suppose that this is the topology and this is X and this is the topology, the subsets of X and satisfy three properties. So if the open sets here, if the sets belongs to topology is called open sets, and interior of A is the all open sets, union of all open sets contained in A. Union of all open sets contained in A, or A containing all the union of all open sets is called interior of A, and the closure of A denoted by A bar or CL of A is the intersection of all closed sets containing A. All the intersection of all closed sets containing A, or A is containing in all the intersection of closed sets. Means suppose that this is the closed sets, this is closed sets, this is closed sets. So the intersection of all closed sets is called closure of A. So closure of A is the closure of A, the intersection of all closed sets containing A, whose contain A inside the intersection of all closed sets is called closure of A. So conclusion is that interior of A is open set, because the union of open sets is called open, and subset of A. Interior of A is open and the subset of A, where A is, we know that A is the subset of X. A is any subset. Closure of A is closed and contains A, means A is the subset of closure of A, means A. So A, interior of A is a subset of A, and the A is the subset of closure of A. This relation is hold. So now we are going to explain some examples related to closure and interior of a set. Let A be a subset of a real numbers with a standard topology. We know that the standard topology, in standard topology all the open sets belongs to all the open sets A comma B belongs to this topology, where A comma B belongs to real number and A is less than or equal to B. This condition, all the subsets or all the open sets belong this usual topology or standard topology. So the interior of A, what is the interior of A? Now I am explaining how to find the interior of A in standard topology, and the subset of standard topology is 0, 1, closed from 0 and open from 1. So according to the definition of interior of A is all the union of open sets containing in A. Means suppose A is here from 0 to 1, 0 to 1, 0 is included and 1 is excluded. So all the open sets containing in A means union of all the open sets. So union of all open sets is here. We can see that the union of all open sets is 0 comma 1. So the interior of A is 0 comma 1 open. Here we can see 0 comma 1. Now I am going to explain closure of A. So closure of A is the all the intersection of all closed sets contain A containing A, sorry, all the open sets, all the intersection of all closed sets containing A. So we can see that the closed sets in real line this types. So our set is A is from here to here. 0 is included and 1 is excluded. So the minimum closed set is whose contain A is 0 comma 1 closed intervals from 0 to 1, because it is the intersection of all closed sets containing A. A contains in this set, so this is the closure of A. This is the answer. Now second example, same subset 0 comma 1, 0 is closed and 1 is open, 0 is included and 1 is not included. Excluded is a subset of real line with the discrete topology. As we know that in discrete topology all the subsets belong to the topology. If we consider the set A is equal to 1 comma 2, so the discrete topology according to this set phi 1, 2 and 1 comma 2, all the possible sets. In this discrete topology we know as we know in discrete topology all subsets are open as well as closed. If we take this is open set 2 is open set because 2 belongs to this topology. And what is the definition of closed set? If the intersection if the complement of this set open set is closed set, so that complement of 2 is 1, so 1 is closed set, but 1 belongs to this, so 1 is open set. Then a complement of 1 is 2, so 2 is closed set but as well as open set. So in discrete topology all the open sets and closed sets are equal, means all open sets and closed sets are clopen, all sets are clopen, closed and as well as open. So now I am going to explain in real line discrete topology. So what is the interior and closure of A? A is 0 close, 1 open, from 0 to 1. 0 is included and 1 is excluded. So all the open sets containing in A containing in A, according to the definition of interior of a set, all the union of all open sets contained in A. So we can see all the open sets here, closed as well as open interval and semi-open interval is also a open sets. So the interior of A is 0 comma 1, same as A, and all and the closure of A. What is the closure of A? A is this 0 comma 1, from 0 to 1, 0 is included and 1 is excluded. So all the open sets, the union of all open sets contained in A. So this is also open in discrete topology because all the subsets are open. So this is open in discrete topology on real numbers. So this is open set and union of all open sets contained in A. So this is the interior of A. Now explain how to compute closure of A in this condition discrete topology on real line. So closure of A, all the closed sets containing A, all the intersection of all closed sets containing A. So as we know, this is also closed because every subset is closed as well as open. So this is also closed, and the smallest closed set containing is also this. So this is the closure of A containing A. So here the interior and the closure is equal to same 0 to 1, close from 0 and open to 1. This is interior and exterior, no, interior and closure of a subset A. Now third example, same subset of real number with cofinite topology. As we know, cofinite topology, all the subsets is open if the complement of these sets are finite or X or whole set. So we have this 0 to 1, 0 is included and 1 is excluded, and according to the definition of interior of the set, the union of all open sets contained in A. So here union, what type of the open sets contained in this topology, cofinite topology? In this topology, these types of open sets, minus infinity to 0 and 0 to positive infinity. So the complement of A bar is 0, means finite set. So finite set. So the closure, the open sets, all the open sets in this set, all the open sets union in this set is no open set contained in this set according to that cofinite topology, because open sets in this type a to infinity, or something like this, minus infinity to a to b, union b to c, means this type of open set from there to here, from here to here, here to here. But we can say in this set there is no open set contained in this set. So the interior of A is phi, null set. What is the closure of A? And what is the definition of closure of a set? The intersection of all closed sets containing A. In this topology, all the discrete one-point set is closed sets and X also. So the intersection of all sets, closed sets containing A. So what is the the intersection of all sets closed? The intersection of all closed sets containing A means X is also closed in cofinite topology, because the intersection of X, the complement of X is equal to phi, so X is closed. So X is closed subset, a closed set containing A only, and the intersection of all closed sets. So this is the closure of A is equal to, the closure of A is equal to all real numbers, because 0 to 1, all the open sets, all the closed sets, like singletons, all the numbers, real numbers, all the real numbers are real numbers are intersection of all the real numbers are closed sets or X. So the intersection of all the closed sets containing A is only X. So X intersection with X is equal to X, means real number intersection with real number is equal to real number containing A. So the closure of A is equal to all real numbers. Thank you. Allah Hafiz.